Okay, so here's a video on how to find the distance from a point to a line. Okay, so we're going to work with this example here. So the line is x plus y minus 5 equals 0, and the point is negative 1, 3. First thing I'm going to do is I'm going to plot these. I'm going to look at these on a graph. This one's easy enough to convert into slope-intercept form, so I'm going to call it y equals negative x plus 5. So if you convert that to slope-intercept form, bring the 5 over and the x over. Okay, so if I go to graph those two, well, I'm going to take a look at this graph here. Okay. First, I'm going to plot the point, negative 1, 3. It's easy to plot. So I'm going to go negative 1, 1, 2, 3. There's the point. So negative 1, 3. So that's point P. And then I'm going to do the line here, which is negative x plus 5. So I know the y-intercept is 5. So I'm going to go up 5. 1, 2, 3, 4, 5. There's the y-intercept. And the slope is negative 1. So I'm going to go down 1 over 1. Okay, so down 1 over 1. So down 1 over 1, that gives me that point there. And I'm going to graph this. Try to graph it nicely. Okay. So there is the line. I'm going to call it line L. Okay. And now we want to find the shortest distance from this point to that line. Well, we can look at it a couple of ways here. So there's the distance from that point to that line. If you go along here, that's not the shortest distance. Just like that's not the shortest distance. The shortest distance is going to be along a line that is perpendicular to the given line. Okay? So we need to draw a line segment that's perpendicular and through that point. Okay. So we want to find that distance. That is our distance. Okay. Well, we need to, in order to find that distance, we need the distance formula, and we also need that point. So let's call that point point S. So we're looking for the distance from P to S. Now, we know about perpendicular lines. We know that the slope of a line that is perpendicular is the negative reciprocal of the original line. Okay, so I'm going to extend this line on beyond that line segment, okay, so that it becomes a complete line. I'm going to call that line K. All right, so we have line L, which is a given line, and line K is a line perpendicular to line L that goes through point P. We want to find this distance. In order to find that distance, we need this point. If we can determine the equation of this line K, this point is just the intersection point of those two lines. Okay, so first thing we did was graph the information, label some stuff, and now we want to determine the equation of line K. All right, so let's determine the equation of the line perpendicular. That's my symbol for perpendicular. Determine the equation of the line perpendicular to L that goes through P. Okay, so that's our first step. So from L, M equals -1. Okay. The slope perpendicular is m equal to positive 1. Okay. So there's our slope. Therefore, so we're going to call this line K. All right. So K is y equals x plus b. So 1x is the slope in there. Sub in p to find b. Okay. So p is negative 1, 3. So 3 equals negative 1 plus b. So b equals 4. Therefore, y equals x plus 4 is line K. All right. So does that make sense? Let's take a look here. It looks like it has a y-intercept of 4, and it has a slope of up 1 over 1, so it looks like it's right. Okay, so now I need to find that intersection point. Now, by observation, that looks like it's at about 1/2, and 1, 2, 3, 4, 4.5. So it looks like it's about 1/2, 4.5. Turns out that's what it is, but we got to prove that mathematically. This is just a nice, nice example that works out nicely, so you can kind of tell that. So you can't guarantee it without the algebra. Okay. So determine S, the intersection point, okay, determine that by using the two equations. So I'm going to use substitution. Okay, so from line L, we've got negative x plus 5, and line K, y equals x plus 4. Let's bring this x to this side and the 4 to this side, and we get 2x, and 5 minus 4 is going to be 1. And then that's going to be x equals 1/2, 0.5. Okay, and that's what we predicted in here. It was going to be about 0.5 there. Now we're going to substitute in to solve for y. So I'm going to sub into L, so the equation for the original given line. So then y equals negative 0.5 plus 5, which equals 4.5. Okay. Therefore, S equals 0.5 and 4.5, or in fraction form, 1/2 and 9/2. So now we're going to determine the distance. Okay. So now we've got point S, the intersection point, and we got point P. So now we just use the distance formula. Okay. So 3, the distance from P to S equals, distance formula, I'm going to do xs minus xp squared plus ys minus yp squared. You could have called it x2 minus x1, y2 minus y1. It's from specifically named points here, so that's okay. So the x-coordinate of S is 0.5. Oh, I shouldn't have that bracket there. So 0.5 minus the x-coordinate from P, which is -1, squared, and the y-coordinate from S, which is 4.5, minus the y-coordinate from P, which is 3. Okay? And so that's going to become 1.5 squared plus 1.5 squared, and plug that into your calculator. And you get approximately 2.12. That's approximately that. Okay. Now, a better answer, a more exact answer, is by using the fractions. Okay. So we're going to use the fractions in here. So dps, again, I'm going to say, use that same formula here, but I'm going to use 1/2 minus -1 squared plus 9/2 minus 3 squared, and that's going to be 1/2 plus 1, and 1 is the same as 2/2, so that's going to be 3/2 squared plus 9/2 minus 3. 3 is the same as 6/2. 9 minus 6 is 3/2 squared, okay, which equals 9/4 plus 9/4, okay, and that's going to be root 18/4. And that reduces to root 9/2, and that reduces to, well, that reduces to 3/√2 if you distribute the root into both, which you can do. Okay, so that is the exact distance. This is the approximate distance.